This video demonstrates how to make manual metal tube bender. This bender is composed of a vise, steel angle, and bearings, enabling me to create perfect curves in metal tubes, allowing me to easily customize various shapes and designs according to my needs. I made some trellis for climbing plants' growth. First, making the nuts to fit the inner diameter of the bearings. M12 nuts were selected, taking into account both the inner diameter of the bearings and their compatibility with other components. The dimensions of the nuts match the bearing diameter precisely, ensuring a secure and reliable assembly. The precision of lathe machining played a crucial role here, allowing to control the cutting tools and feed speed to ensure the accuracy of the nuts dimension. During lathe machining, special attention was given to tool selection and grinding to ensure a smooth surface on the nuts. This is crucial to reduce friction between the nuts and bearings, thus enhancing overall performance and lifespan. In the second part of the project, the nuts were welded onto the steel angle. This step is critical in the entire construction process, and the positions of the 3 nut welding points needed to be accurately calculated. 3 nuts, machined on the lathe, were welded onto 2 pieces of steak angle. 2 nuts were welded onto 1 piece of angle iron, and 1 nut was welded onto the other. The positions of these nuts formed an equilateral triangle, ensuring parallelism during subsequent assembly and use. During welding, the internal threaded portion of the nuts was securely attached to the steel angle, ensuring the strength and reliability of the components to withstand future stress. Additionally, it was important to ensure the external surface of the nuts remained smooth to avoid contact with the welding wire, ensuring smooth rotation during assembly. In the following step, the bearings and the previously welded nuts were assembled onto the vise. Precise calculations were made to determine the angular movement distance between the 3 bearings, based on the spacing between the bearings and the diameter of the metal tube. This step was crucial as it ensured the bracket could achieve the required curved bends during use, making it an efficient metal tube bender. This project also addressed the bending needs of many other projects, making it highly versatile. Different solutions were attempted initially, with the use of the cast iron blocks provided with the vise to secure the bearing assembly. However, a more stable method was chosen later on. Another piece of iron was welded onto the steel angle, forming a robust triangular structure. This design ensured that the steel angle wouldn't deform under high-stress conditions, increasing the stability and reliability of the entire bracket. Finally, the bending process of the tube bender was demonstrated to ensure metal pipes were bent according to the desired curves. First, determine the desired curvature for the bend and calculate the bending distance based on the desired curve's radius. This can be achieved through mathematical calculation or measurements using marking. During the bending process, gradually increase the curvature by a certain degree each time. This can be achieved by gradually adjusting the vise. Repeat the above steps until the desired bending curvature is achieved. This may require multiple bends and adjustments to ensure the shape of the metal pipe conforms entirely to the requirements. Through this process, it is possible to create metal tubes with the desired shapes as needed. This precise control allows for customization of various shapes and designs, ensuring that each metal pipe meets design and functional requirements.
するから。